Can you all see my screen, right?
Yes,
Yes.
we can.
Yes, we can.
Thank you. Today's session is based on the application of differentiation, right? Remember when I first introduced the derivatives, the differentiation theory, I said derivatives are used to analyze the change of variable of various quantities such as cost, total cost, revenue, profits, and it helps in decision making when it comes to business, right? Because with derivatives, you can tell whether you are making a profit or when to produce, like how many quantities can you produce to maximize the profit, and what is the minimum that you should not produce that will result in the cost, yes, or the minimum profit. It helps with that. So today we are going to start with the application of those derivatives of the theory that we've been doing so far. So we are applying that theory to what you did with Prof. Mathematics, right? So after today's class, you should be able to explain the concepts of revenue and marginal revenue, or also the cost. And you should be able to know how to, like, you should be able to know how to use the differentiation to optimize the economic functions like revenue, cost, and profit function. Like this means you should know how to maximize the revenue, profit from the theory of differentiation. Okay, I'm not sure whether we'll get to the interpretation, like to know how to determine and interpret the elasticity and or of nonlinear demand. Yes. So we have 3 objectives. They are all based in the application of differentiation. Okay, starting from the marginal and average function. Okay, in the previous chapters, the ones that you did with Prof, oh, no, the one that you did with me, again, the theory of differentiation. Okay, we said the derivative of a function, we introduced it as the equation for a rate of change of the function, right? And in economics, the rate of change of which the total revenue changes is called the marginal revenue, meaning if you differentiate the total revenue, you should get the marginal revenue, right? Okay. Marginal revenue is the derivative of the total revenue with respect to the quantity. Okay. In weights, this means the rates at which the total cost, oh no, the rates at which the total revenue changes is called the marginal revenue. And again, that and again, the total rate, the total cost at which, no, the rate at which the total cost changes is called the marginal revenue. And this means the marginal cost is called the marginal cost. Okay, this means if we differentiate the total cost with respect to the quantity, you will get the marginal cost. Marginal cost is equal to the derivative with respect to Q of the total cost. Okay. Yeah. First, we have equation 1. It says the rate at which the total revenue changes will give us the marginal revenue. Then equation 2 means the rate of change of the total cost will give us the marginal cost. Okay. And okay, this means you differentiate the total revenue, you get the marginal cost. You see, that's where the derivatives comes in, because we are differentiating here. Remember, d over dq of a function. Okay, let me just say f at x. This means you are differentiating f at q with respect to q. And again, we have this sign d over dq, d of this sign, meaning we're differentiating again. That's where the derivatives comes in. That's why this chapter is called the application of the derivatives. Okay. Again, let's go back to the marginal revenue. Okay. The marginal revenue, this is just the additional income that generates from the sales of one more unit of a good or service, right? And yeah, in your book, the study guide, marginal revenue, they defined is as the increase in the revenue that results from the sale of one additional unit of outputs. Okay. Yeah. By analyzing the marginal revenue, it helps the company to identify the revenue generated from each additional unit sold. Like it helps the business to know how much revenue is generated if they produce one more. It's either demand quantity. Yes, let me just use the word quantity. Okay, and this simply means knowing the marginal revenue, it will help the company understand the demand for a product in the market. Like how much product should they produce to meet the standards of the market. Okay. Let's say if the demand function is given as P equals A minus BQ, right? Let's say this is a demand function. This is a demand function for maybe any products. You can give it to it for any products. Then, okay, we can find the total revenue of this function by differentiating. First, this is the demand function. So this means we can find the total revenue by multiplying this function by the number of units demanded. Okay, we use Q for demand, units demanded, and then P. Okay, these are just constant, right? Okay. We said this is the demand fund, right? And so, okay, from here, we can find the total revenue by multiplying with the number of units demanded. Okay, so this means total revenue is equal to these equations times the quantity times the number of units demanded, right? And we know that P is represented by this function equals to this function. So from here, if we substitute the value of P, we'll have A minus B Q times Q. And if we simplify this, we should have A Q minus B Q squared. Okay, this is just the total revenue, right? But remember, I said the marginal, okay, what can we find from the total revenue? We said, remember we said the marginal revenue is the derivative of the total revenue, meaning if we differentiate the total revenue, we can find the marginal revenue. So from here, another information that we can find is the function that represents the marginal revenue. Okay, first we were given the demand function, right? The demand function. From the demand function, we said, what can we find from this function? What more information can we get from this function, right? And then we said a formula. Remember, I think from unit 1, you said the formula for finding to find the total revenue from the demand function, you can just multiply that demand function with the units, with the number of units demanded, right? That's why we multiply this with Q. But remember, this formula is given on the first unit, right? Okay, then this is what we obtained. Then what more can we find? What more can we find from this information that we have now, right? Then remember I said to get the marginal revenue, you have to differentiate the total revenue with respect to the quantity demanded, the number of units demanded, right? We have this, which is this, right? Okay, so we just have to substitute it here and differentiate. Okay, this means we have d of the q of a q minus b q squared, right? Okay, you see, we are differentiating q with respect to, okay, we are differentiating this function with respect to q, right? Remember, I said a and b, those are constant, right? Okay, then you go back to the rules of differentiation and check which rule can you apply here to differentiate this function, right? That's where our rules of differentiation comes in. Okay, you know, to differentiate q with respect to q, you have to use the power rule, the rule 1 of differentiation, the one that I introduced as rule 1. So, okay, if you compare this to rule 1, remember rule 1 is, okay, f at x equals to x to the power n. If f at x equals to x to the power n, then the derivative of this would be n x n minus 1. right? If you compare these two, you can conclude from here that your n is 1. So just come here where there is n, put 1. If you do that, this is what you'll obtain. A. You'll have A times 1, which is just A. Because you put, okay, you put 1 here. If you put 1 here, that means you'll have 1. You'll have 1 times x to the power 1 minus 1. This is 0. X to the power 0 is 1. So this means you have 1 times 1, which is 1. That's why we have, that's why I said we have A, because we'll have A times the derivative of this. We said the derivative of this is 1. So there's no need to write 1. That's why I just said it's A. Then we differentiate this. We have q squared. Again, you use the power rule here. So where there is n here, just substitute n with 2. So this means you'll have minus b times 2q. And if you simplify this further, you'll have a minus 2bq. And this would be your marginal revenue function, the function will represent the marginal revenue. If you were given this function, which is the demand function, from this function you can find two things. Okay, you can find the function that represents the total revenue, and you can also find the function that represents the marginal revenue. Okay, let's try an example, another example. Okay, suppose you are given a demand function P equals 10 minus 0.3 Q. Okay. Let's say you are asked to find the total revenue and the marginal. Okay, let me just say the marginal revenue, because before you find the marginal revenue from here, you need to find the total revenue. Or maybe let's say the question says, okay, I'll continue with the question, but for now, let's just find the total revenue. Okay, you said if you are given a demand function to find the total revenue, you need to multiply that demand function with the number of units demanded. So this means we have P times P is 10 minus 0.3 Q times Q. Then you simplify this. If you do, you'll get 10Q minus 0.3 Q squared, right? But remember, I said the question says you should find the marginal revenue. But you know that if you have the total revenue, you can find the marginal revenue by differentiating the total revenue. So this means we have marginal revenue equals to the derivative of total revenue, which is d over dq of 10q minus 0.3 q squared, right? Okay, and this will give us 10 d over dq of q minus 0.3 d over dq of q squared, right? Okay, if you differentiate here, what would be what is the derivative of q, right? If you differentiate here, what are you going to get? Okay, you're going to get 10. You will get 10, right? Because here you'll have 1 times 10 is 10, right? Then minus 0.3 times. If we differentiate q squared, what is the derivative of q squared? Is 2q, right? 2q. Then the next step is to simplify. If you simplify this, that you will get 10 minus 0.6 Q. And this is your marginal revenue if you were given this as the demand function, right? Again, remember I said the marginal revenue is the additional income that can be generated from the sale of one unit of a good or service. Like again, in your book, they said the marginal revenue is the increase in revenue that results from the sale of one more additional unit, right? Now, suppose you were told that they've sold how many units? Let's say they've sold 15 units. Now, the question is, what is the marginal revenue from generating one more unit from there? Okay, you are told that they've sold 15 units, right? And then the question is, what would be the marginal revenue of the next unit to be sold? Like, how much of the marginal revenue are you going to get if you sell the 16th unit, like the 16th products? Okay, this is how you're going to solve for that. You'll go to the marginal revenue where there is Q, you'll substitute that with 15. Okay, so we have 10 minus 0.6 times 15, right? If you solve this, you should get, okay, we have 10 minus 0.6 times 15. This is 1, right? Okay, I'll just say this is 1 rand, right? So this simply means that the 16th unit to be sold will generate an additional income of 1 rand. Okay, if maybe you were asked to find the total, like the marginal revenue, what would be the marginal revenue of maybe the 11th unit to be sold? Like, how much income are you going to get after? How much additional income are we going to get after selling 10 units? Okay, again, you'll go to the marginal revenue function that you obtain. You'll have 10 equals 10 minus 0.6 times 10, right? So this will give us 4 rand, right? So this simply means after 10 units have been sold, if you sell one more unit, you'll generate an additional income of 4 rand. Okay, before we move, do we have questions, comments, queries? I don't want to lose you.
I was just going to ask something.
Yes. Okay.
Yes.
I'm just noticing on the answers that the more units you add,
I'm listening.
sorry, if you can go back to your 2 examples right now.
Did you guys said there's a question, or you said you're still fine?
Yeah, I was just referring to the examples you just made now. Can you just go back to both of them, the answers? Can you hear me?
Okay, let's move on. That was the marginal revenue. Let's move on to the marginal cost.
No, there are
Sure.
questions. I'm not sure if you could hear.
Yeah,
that,
we do have questions, ma'am.
But I asked, you were all quiet.
No,
Okay,
someone
I'm
was
No,
listening.
talking.
you are not hearing us.
No.
We are talking. I think your network is very bad.
Yo, okay. Let me get my Wi-Fi and connect with my phone. Just give me a second. You can ask in the meantime.
Okay, you switched off the page I wanted to refer to.
Okay, I'll go back to it.
Sure.
Just a second.
Okay.
Okay, I'm back. Is it better now?
Yeah, we can hear you. Can you hear us?
Yes.
Okay. You can just go back quickly to the, yeah. Just up a bit. Yeah, thank you so much. Oof, you went too far up. Just the answers at the bottom. Just the two answers. Scroll down.
Why is my thing not working? Yes. Oh. I think it's fine now.
I just want the answers right at the end, bottom of the page.
10. At the end,
Yeah, the
you mean
marginal
for
revenue for 15 units and the marginal revenue for 10 units, just at the bottom.
Yeah. It's 1 rand and 4 rand.
Yeah. So what I was noticing is that as the units, you see the 15 units, it gives us 1 rand's profit when you're adding more units, and the lesser the units, the higher the profit, because with 10 units is 4 rands and with 15 is 1 rand. It doesn't make any sense. I'm not sure, maybe is there a way to explain that, like in terms of realistic profits now, like what would, when you are adding more units, you're getting less profit and then, or marginal revenue?
Maybe it's just this function that I'm using, because I just took a function from my head, then I used it. But another thing, it has to do with the maximum profit.
Maximum profit.
Yes, because sometimes if you produce more units, you might end up not making enough, like not making a profit. Maybe if you produce more than what's the market,
Demand.
more than what's in the market is required. Yes, I think it has to do with that. But here I just took any random function. I used it here.
All right. No, I just wanted the logic behind this. Okay, no, thank you so much.
Ma'am.
Do we have any more questions?
Hello.
Yes, we do.
Can you hear me?
Can you guys
Yes,
hear
we
me?
can hear you.
Oh, all right, thank you. And there's
Can you hear us?
yes.
Okay, so what I wanted to ask, when you go up on that Q and QD over Q, If you can just go up a
Which
little
part?
bit. That one. That one.
Yeah.
10q over, no, again, please go down a little bit. Yeah, this one where it's d over dq 10q 0.32q. So I got the function how you got it. But what I don't understand, it's the middle part. Do you just cancel dq over dq and then you're left with 10? And then you just say minus 0.3 that demand functions, and then that q squared, you just say 2q. Is that you just cancel out like that?
Nope.
Or is there a specific calculation?
You are using the rules of derivative differentiation rules, the one that I used here. Remember, here we had the same thing, dq over dq, right? Then I said, if you compare this q with this function, this means your x is q and your n is 1. So if your n is 1, then the derivative, that's the derivative of this function is this, right? So
Yes.
just come here where there is n, you put 1. Where there is n, you put 1. That means you'll have 1 times q 1 minus 1, right? This is 1 times q to the power 0. We said this is equal to 1, right? So this simply means we have 1 times 1, which is 1. That's why here I just said 10, because I assume you guys, you have mastered the rules of differentiation by now, because we stayed there, we even did the tutorial on these rules, because if that the reason I stayed so much on that topic is because I knew we were going to use it from the rest. Okay, on all the chapters remaining from the rest of the chapters.
Okay.
So that's why here I'm not like going back to the rules. I'm not showing you step by step, because we did the rules already.
Okay. All right. No, noted. Thank you so much.
But please go back to them. If you have a question, you can ask the e-tutors or you can ask me. It's fine.
Okay. Thank you so much. Thanks for that. I'll do so.
No problem. Okay. Can we move on to the marginal cost, or we still have questions?
Hi, Nolwazi. Tembisa here. Sorry, I didn't
Is it
raise-
my network or yours?
I can hear you. I think it's my network. I'm not shaded. Can you hear me?
I can't hear you. Is it just
Is
me
it?
or everyone?
We can hear you.
We can hear everybody.
Oh, can hear.
Can hear.
Yeah, I
Okay.
think I had the
You can
same
ask.
question with Masondo. Yeah, because I thought the DQ cancelled each other.
You can
But
still
like you are
hear
saying that
her.
we need to
Guys, you can still hear her.
Yes.
Yes, we can hear you.
Yes. Yes. No, I was saying that my question, I think, is the same as
Alright, I'm
Masondo,
listening. You
because
can
I
ask.
thought that, yes, I thought that DQ cancelled each other. I think I had the same question with Masondo, that DQ and DQ cancelled each other. But like you are saying that we need to emphasize on that rule. I think I'm fine.
Is there anyone of you has a radio on?
Someone that needs to be muted, yes. Kenele Ways. I think that's her name.
I think it's Canelo, yeah.
Pinelo, you can
That's
mute your
fine,
mic.
Olas. We can continue. Yeah, we can
Okay,
continue. That's
Just
fine.
a second. I'm gonna mute all of you, and then the one who has a question will unmute. Okay, please unmute your mic, okay? And ask.
I'm fine, Olazi. I had the same question with S. Masondo. Yes, I'm fine. Thank you so much.
So I did answer you.
Yes, yeah, like I said, that we need to emphasize on the rule. Yeah, because I said DQ cancelled each other, but that's fine.
Oh, all right, no problem.
Yeah, thank you so much. Thanks.
Thank you. Okay, guys, let's move on to the marginal cost. Okay, the marginal cost is just an increase or decrease in the cost of producing one more unit or service, or saving one more customer. Okay, then in your book, they use this definition. They said a company's marginal cost is how much extra it costs to produce additional units or goods or service. Okay, so knowing the marginal cost will help a company understand when it's no longer profitable to manufacture additional goods. Right. Okay. So, okay, let's do an example. Let's say you are told that a company sells phones for 5,000. Okay, each phone, each phone costs 5,000. Okay, and it has an additional capacity to manufacture more phones, right? And maybe one company approach them and offer them to buy 100,000 phones for 4,000 each. Marginal cost is one component needed to analyze whether it's make a sense for a company to accept this special offer or not. Okay, we are told that the company sells each phone for 5,000 rand, right? And they have a capacity to manufacture more phones, right? Then another company approached them and said, okay, they want to buy 100,000 phone, but at a price of 4,000 each per phone. Okay, now the marginal cost can assist the company here because it can help it analyze whether it makes sense for them to produce 100,000 phones. Are they going to make profits if they produce such a number of phones? Okay, and from the first unit, we said the total cost consists of the fixed cost and the variable cost, right? This is the equation that we use for total cost. Okay. The reason I'm going back to the total cost is because we said if we know the total cost, then we can differentiate it to find the marginal cost. Okay, from the information that we were given from the scenario, we said for this company to make a decision whether they are taking this offer, they need the marginal cost to analyze whether they will make profits or not. Okay, that's the reason why I'm starting from the total cost, because if we know the total cost, we can use it to find the marginal cost. Okay, and we said the marginal cost is the derivative of the total cost. And the total cost is the fixed cost plus the variable cost, right? So this means the marginal cost is the derivative of the fixed cost plus the derivative of the variable cost, right? But talking about the fixed cost. We know that a fixed cost is just a number, it's a constant, it can be any variable, right? Since the fixed cost, it's a constant, this means this part, okay, my pen stopped working. Okay, this means this part is out because is equal to 0. Remember, the derivative of a constant is equal to 0, right? So this means the marginal revenue, the marginal cost is the same thing as the derivative of the variable cost, since this is a constant. And we said the derivative of a constant is equal to 0, and the fixed cost is a constant. So this part is 0, then we are left with this part, meaning the marginal cost is equal to the variable cost, right? So this means if you are given a total cost and you want to find the marginal cost, since the total cost consists of the fixed cost and the variable cost, you can just differentiate the variable cost and that would be your answer. So suppose we are given a total cost as C equal to 1,000 plus 35Q, right? And then you are asked to find the marginal cost. The marginal cost for this, if you are given this as a total cost function, the marginal cost would be a derivative of 35Q, which is 35, right? Because this is a fixed cost, right? And the derivative of this is 0. So you can just differentiate this and that will give you the marginal cost, right? So this means that the outputs of each additional unit will give you will cost you 35 rand if you were given that this as the total cost, right? Okay. Let's say now we are given our total cost as C equals 1/2 Q squared plus 100. Let's say we are told that this function represents the total cost. If you look at this function, right, from here you can conclude that the fixed cost is 0, right? There is no fixed cost. You only have the variable cost. So this means your marginal cost would be this whole function. So this means you'll have d over dq of 1/2 q squared plus 100q, and this will give you q plus 100, right? So this means when maybe you are told that the quantity of producing a cost, or of like the quantity produced or sold is equal to maybe 10. Now let's say you are asked to find the cost of producing the 10 more quantity, or just 10 units, then you will go back to this equation which represent the marginal cost. You'll have marginal cost equals to 10 plus 100, and that will give you 110. And this simply means the cost to produce the 11th more units is 110 rand. Do we have questions?
No. Yes. Do you say the cost to produce 11th more?
Nope.
Okay.
They,
So this is the cost of producing
is it my
10
network
units
again?
more. Hello?
Yes.
Did you say this is the cost
Hello?
of producing 10 units more? Jesus.
Ms. Nkomo, can you hear
Yes.
us?
Yes, I can hear you. It was just here that I couldn't hear.
No,
Yes, she was
did you
breaking.
just say that on that equation
Again,
when we have to find that 110, is it
Bonani.
the cost of
Yes, I think I should ask on her behalf because I think you can't hear her.
Yes, please.
okay?
Kumbelo is asking the function that you just gave us now, is it sorry, the marginal cost, is it a marginal cost to it is the cost that we incur for producing the 11th unit or the 10th unit?
The 11th unit.
I think that's where now she's going to ask how, because you're writing 10. The Q is 10 and not 11. If you can explain that part. Kumbela, is that a correct question to ask?
Yes, it is.
Okay, I think I'm Jesus. I'm the mediator between you and Nkomo
Oh,
here.
Jesus.
Remember we said the marginal revenue, right? Oh, no, the marginal cost. That is just the cost in the increase or decrease in producing one more unit, right? Or saving one more customer. And here we were given the quantity as 10. If we were given a quantity as 10 and we are asked to find the marginal revenue, that means we are asked that means the question seems you are asked to find the cost of producing the 11th unit. So if you are given 11, your Q as 11, your quantity as 11, that means you are asked to find the cost of producing the 12th unit, since the marginal revenue is the cost of producing one more unit. Is it fine?
No, it's not.
She says it's not. But I think a lot of people have got it, because you're saying if ever the quantity
Yeah,
is 10, it
yes.
means we are asked like how much would it cost to produce the 11th. So don't focus on the number that's written, Kumelo, just add one more. And the answer, the marginal cost is the additional of one more of that quantity.
Is that correct?
Got it, Kumbelo?
Okay. Yeah, okay. I got it. I mustn't focus on the number that is given.
Yeah, just add
Okay.
one more is the answer.
Just add one more. All right.
Jesus makes
Straightforward.
things
Thank
easy.
you.
Thank you.
Yeah, Jesus, thank you.
Modimo.
Ngwana wa Maria o tswa Modimo.
Okay, let's move on to the average revenue and cost functions. Okay. Starting from the average revenue. Okay, that's just the function that is used to express that can that gives an expression for an average value of maybe the economic variables over an interval. Yeah, then in your book, let me see, I said the average revenue, it helps in estimating the profit of a business, as the profit is calculated by subtracting the average revenue from the average cost. So this means the average revenue is just the revenue per unit of output, right? Mathematically, average revenue
Hello,
is represented. Yes.
can you please repeat how you define it again? Not the textbook.
Okay, that's just an expression for the average for an average value of economic variables over an interval, right?
Okay. Thank you.
Just the revenue per unit of outputs.
Okay, thank you.
Okay, and mathematically, it's represented as the total revenue divided by the quantity of outputs, the number of outputs. Okay, from this equation, right, we can, let's say we are given a total, like an average revenue, and we are asked to find the total revenue, right? Remember, we said an average revenue, it's a revenue per unit output, right? So if we are given that's average revenue and we are asked to find the total revenue from this equation, you can say the total revenue would be an average revenue times Q, which is just the units demanded or produced. Okay. Since the total revenue is defined as the total revenue equals to the, okay, we said total revenue is equal to a demand function times units demanded. Okay, and again, now I'm saying the total revenue can be found by multiplying the average revenue with the demand or the quantity, right? So from this information, this means the average revenue is equal to the demand function, meaning the average revenue equals to the price with the given, that would be given by the demand function, right? Does this make sense? If total revenue is equal to P times Q, and again, we are told that the total revenue is equal to AR times QR. This means this is equal to this. Since these two are equal, okay, we have P times Q equals to A times Q. That means we can divide. If we divide with Q on both sides, they will cancel. We'll have P equals average revenue. That's where this comes from. Okay, so this means we can find the average revenue by calculating the demand, by calculating the price from the demand function, right? That's function, so does say, I think it's P equals A minus BQ. we can use again this to find the average revenue. So if this was the demand function, the function that's used to represent the demand. Okay, let's move on to the average cost. Again, the average cost, this is just the total amount of all the production cost divided by the quantity of output produced. Okay, the average cost. What? This pen doesn't like me today. Just give me a second. Average cost. We said average cost. This is just the total amount of all the production cost divided by the quantity of the output produced. So this simply means we have the total cost divided by the quantity produced, and this is the average cost. So for okay, this okay. The average cost. Say you have a business and you know the average cost. The average cost will help you in making price decision. Like, because any price that is below the average cost, it will result in financial loss. Right? Okay, any price below this will result into a financial loss. So knowing this will help you decide on, like, giving price to your products that you are selling or service that you are giving. Yeah, depends on the nature of your business. Okay, so from this, it follows that if the average cost is known, then the cost is given by the average cost multiplied by the number of units produced. Right? So if we know this means this part, the total cost would be the average cost times the number of units produced. Okay, again, from here, I just multiplied to find this. Okay, it's also from there. Okay, let's do an example based on this, what we did, the average revenue and the average cost. Okay, suppose you are given a demand function for any products, and you are given as P equals 300 minus 12Q. Okay, here, this is just the demand function, right, for any products. Okay, from this information, we can find the total revenue, right? Since we said that the total revenue is equal to the demand function times the units demanded, right? Okay, so this means we have 300 minus 12Q times Q, and this gives us 300Q minus 12Q squared, right? But what more can we find from this information that we have? Since we have the total revenue, we can find the marginal revenue. Remember, we said the marginal revenue is equal to the total revenue. The the marginal revenue is the change in total revenue, meaning differentiating the total revenue with respect to the quantity demanded, you can find the marginal revenue. So from here, we can find is equal to T of R with respect to Q. Yes, I'm listening.
Okay, since you said that AR is equal to P, so in this case, are you saying that AR is equal to 300 minus 12Q?
Yes.
Okay, thank you.
Okay, we have 300 minus 12Q squared, right? And if we differentiate this, we'll find 300 minus, that's 24Q. And this is the marginal revenue. So we have the demand function, we have the total revenue, we have the marginal revenue. What more can we find from this information, right? Remember, we said the average revenue is the revenue per unit output, meaning AR is equal to TR over Q, right? And what is our total revenue? We said our total revenue is 300 Q minus 12Q squared. Okay, we are dividing everything by Q. If you divide everything by Q, you should have 300 minus 12Q, which is what you said, the average revenue, right? What more can we find from this? Can we find anything from here? Okay, we are given the total, we are given the demand function, right? And we said we can find the total revenue. From a total revenue, we find the marginal revenue. From the marginal revenue, you find the other. Okay, again, from the total revenue, we find the marginal. Okay, guys, this is not how you are going to ask this question, right? Maybe they can just give you the demand function, and then they will be like, find, okay, what is the marginal revenue of a demand function given as in this function, right? Then you know that function, from a you can find the total revenue. From a total revenue, you can find an average revenue, right? They won't ask you, they won't give you a demand function and say, what can you find from this information? Again, they will give you a demand function and ask you to find the marginal revenue. You know that before, okay, the marginal revenue is the derivative of the total revenue, and you can find the total revenue from the demand function. Right, now I'm just asking you what more can we find, because it's just I'm teaching that you can, what information can you find if you're given such function. Okay, now, oh, before we move on, do we have questions? Yes, no?
No questions.
No question.
No questions.
Okay, let's do another example.
Hello,
Yes, I'm listening.
ma'am.
I'm listening.
The 300 minus 12Q, did you derive it to find 300 minus 12Q?
I
Or did you just
divided, no, I divided with Q. I divided everything with Q. So this means I had 300 Q divided by Q minus 12Q squared divided by Q. If we divide 300Q with Q, you have 300. If you divide minus 12Q squared with Q, you'll have minus 12Q.
Oh, okay. I thought
I
maybe
just
you'd be
use
right.
this formula.
Okay.
Okay. Suppose in another example, you are given an average cost function for any product, maybe for a certain product, as average cost equals to 3Q plus 20Q plus 6. Okay. Let's say you are asked to find the total cost, or maybe you are asked to find the cost to produce one more product after 10 units have been produced. Okay, you are given an average cost, right? And you are asked to find the cost to produce one more additional unit after 10 units have been produced. Okay, this means you are asked to find the marginal cost after 10 units, the cost of producing the 11th unit, right? Okay, you are asked to find marginal cost of 10. Okay, you are given an average cost. Okay, and you know that the marginal cost, you can find the marginal cost by differentiating the total cost with respect to the quantity. Right. Okay. You know that the marginal cost is the derivative of a total cost, but you are given an average cost. Okay. But you can find the total cost by multiplying the average cost with the units produced or to be produced, right? So this means T total cost is equal to an average cost times the quantity demanded. And you know that the average cost is, we said it's 3Q plus 20 over Q plus 6 Q. Okay, if we multiply and simplify this, you'll have 3Q squared, right? Plus 6Q plus 20. And this is the cost, the total cost function, right? Okay. We have the total cost function as in this function, right? Remember, we said a total cost consists of the fixed cost plus the variable cost, right? Fixed cost is always a quantity. So if you look at this function, you can conclude that the fixed cost is equal to 20 and the variable cost is equal to 3Q squared plus 6. And we said the marginal cost is equal to the derivative of a total cost. But again, we said since the total cost consists of the fixed cost and the variable cost, and the derivative of a fixed cost is 0. So this means the marginal cost is the derivative of the variable cost, right? So this means the marginal cost is d of the q of q. And if we take this, you will have 6q plus 6, right? But the question was, what is the cost to produce one more unit of product after 10 units have been produced? So this means our answer would be C of 10 is equal to 6 times 10 plus 6, and this gives us 66 rand. Do we have questions? Yes.
I don't think there are any
Still
questions.
with me?
I
Yes,
also don't think there's any
We're
questions.
sending reactions, ma'am.
No question. Can you see our reactions as you are presenting?
Nope.
Just for
I
curiosity.
can only see the strength. That's why I keep on coming back.
Okay, ma'am. We understand the implementation of how ma'am is explaining it. Compared to those formulas in the first section of the book. So it's not self-explanatory, but it's at least ma'am is explaining it very decently.
Yeah, I agree.
Thank you.
Is your battery charged, ma'am? We don't want to lose you.
Oh.
Just asking.
Hi, ma'am. Can you please scroll up a bit? I just want to copy everything because I was just looking while you were explaining. I didn't write down.
When this comes to copying, you should use the recording.
Okay.
Because in class we don't have much.
Okay.
I should go up until where?
Yeah, it's fine.
You sure?
Yeah, it's fine.
All right, thank you. Okay. Let's move on to another section. Production function. Okay, during any production function process, units are transformed into units of output. And examples of outputs includes labor, physical capital, raw material, technology, and many more. Those are the examples of inputs. Okay. I said during any production process, outputs are transformed into units of output. Inputs are transformed into units of output, right? So a production function gives the relation between the inputs and the outputs, because we transform the inputs into units of outputs. So the function that's used to represent the production function. Okay, it gives the relation between the inputs and the outputs. Okay, in generally, this function that level of outputs, which is Q. There goes my pen. Yeah. Okay. The output Q is equal to, let's say, a function of L, we'll use L to represent the labor, physical quantity, physical capital. We have raw materials, and we have technology, and so many more. This represents the inputs, and this represents the outputs, right? So we are transforming this to get the outputs, right? But in this module, we assume that the inputs, like the what is capital, physical capital, raw materials, and technology inputs, will assume that those are all fixed, right? We'll only consider the labor as the non-fixed inputs, right? So this means our output would be the function of physical labor. Okay, I'll use L to represent the physical labor. Okay, and then another thing that you need to know is that the marginal production of labor is just the differentiating. Okay, it's just the change in the labor function with respect to the labor, the units of labor, yes, or the amount of labor. Meaning, if you are differentiating, okay, remember I said, I don't want you guys to confuse this Q, which is the demand, and the one that I'm using here, which is the labor function, right? But here we're now talking about the labor function. And I said the marginal production of labor is just the change in the labor function, right? So this means the marginal production of labor is the derivative of labor function. You will find the marginal production of labor by differentiating the labor function. Okay. And then I think in your book that said the marginal production of labor is the increase in the total production that occurs when the labor increases by 1 unit, but all the other outputs, other inputs remains the same, right? Remember, I said in this module, we consider other inputs fixed quantities. So this means the marginal production of labor is the increase in the total production that occurs when the labor increased by 1 unit, meaning this when it's increased by 1 unit, we keep the others the same because they are constant anyway. They are fixed constant at the end of the day. Do we have a question before we do an example? Do we have an example? No, it's still not an example. Still have to do yeah, the example. Okay, knowing the marginal production of labor, that helps the company in hiring decision, right? In economics, the marginal production of labor is the change in outputs that results from employing an additional worker, right? We also find the average production of labor to be the production function divided by the number of labor units. Okay, now we have an average production of labor. This is just the production function divided by the labor units. Okay, we have the marginal revenue. No, the marginal production of labor as the derivative of the labor function, right? And we have the average, production of labor as the labor divided by the divide by the labor units. Okay. Again, the average production of labor is the measure of how the average amount of outputs each worker can produce. Okay, so we have the marginal production of labor. That's helps us in that's just the change in outputs that results from employing one more additional work. Then we have the average production of labor, and that tells us the amount of outputs each worker can produce, and the marginal production of labor helps us in the outputs that can result if a company hires one more worker. Then after hiring that one more worker, we have the average production of labor that can tell us what will be the amount of outputs after hiring that one more worker. Okay, suppose you are given the production of labor for a day. Okay, the production of labor is Q equals 19 L squared minus 0.9 L cubed, right? Okay, we know that this L represents the inputs. Okay, this function represents the daily production, right? So if this is a daily production, that means our inputs is the number of workers, right? Okay. What can we find from this information, right? Okay, we are given the marginal the production of labor function. Okay, and we said we can find the marginal production of labor by differentiating the production of labor function. And again, we can find the average production of labor by dividing the labor function with the units produced or the number of workers, since L represents the number of workers in this case. Okay, now the question is when 10 more workers they work per day, since this function is a daily production function, represent a daily production function. So if 10 workers are employed per day, employing one more worker, okay, let me say, what would be the average production of labor if we employ one more worker? Okay, this is just the daily production function, right? Okay, now we are told that daily we have 10 workers working. Now, what would be the average production of labor if we hire one more worker. Okay, and you know that the average production of labor can be obtained by dividing the labor function with the number of workers. So this means our average production of labor equals 19 L squared minus 0.9 L cubed divided by L, right? You divide this by this, you'll find 19L. Divide this by this, you'll find minus 0.9 L squared, right? But we were not asked to find the average production of labor. We were asked to find the number of the average production of labor if we hire one more worker, right? So this means we have 19 over, okay, so APL. Usually we have 10 workers working daily, right? We want to find the average production of labor if we hire one more person. So this means we have 19 times 10 minus 0.9 times 10 squared, right? So this means we have 190 minus 90, and this gives us 100, right? Okay, since the average production of labor is equal to 100, if daily we have 10 workers working, so this means the average productivity per worker is 100 units, right? So this means if we hire one more person,
Sorry, ma'am.
yes.
Don't you mean when you say when you hire one more worker, isn't that applicable only to the marginal production of labor, not the average?
Oh, yeah. Here I'm just calculating the average production per week.
Yes.
Yes. Okay. If we have 10 workers working daily. Right. Then, yeah. Then the next question is, what would be the marginal production of labor if we hire one more person? Okay. We are told that daily we have 10 workers. And if we hire one more person, what would be the marginal production of labor? Okay, that's where it comes from. And we know that the marginal production of is we get the marginal production of labor by differentiating the function that represents production of labor. So this means we have MP L equals to D of P with respect to L. And our P is, we have 19 L squared minus 8 minus 0.9 L cubed, right? Okay, so this means we have 19 D of DL of L squared minus 0.9 D of DL L cubed, okay? And if we differentiate this, we will have 19 times 2L minus 0.9 times 3L squared, right? And this will give us 38L minus 2.7 L squared, right? Okay, but we are asked to find the marginal production of labor after hiring one more worker. So this means we have the marginal production of labor of 10. Yes, I'm listening.
Can I ask a question? There was P, so I just want to know where did P go? Or maybe I didn't catch right. If you scroll
This
up.
P,
Yes.
it's this P. Remember, we were given. Okay, this is P. It's my right saying it's P. We're given P as this. So where there is P, I substituted P with its function.
Oh, okay.
Okay, so we have 38
sorry, ma'am.
minus 2.7. I'm listening. Times
Isn't
10.
that supposed to be Q? Because the function, yeah.
Okay, but there you can represent your function with any variable, unlike the demand and profit. Okay, for demand and profits here, we always use P and D, right? But for a function like this, okay, like for a daily production function, you can use any variable. You can have P equals to that function, but just make sure that the inputs, the production, the workers, the number of workers is given as L. That is the standard variable that we are using. We'll be using. Okay, that's what they're using even in the book. Okay, but since I started with P, that means I have P here. So if I start with Q, I will have, because remember here on the derivative it can be like I can differentiate any function here, but yeah.
But ma'am, you did start with Q, like the first
I did
function.
start with Q.
Yes,
So
the function is Q equals 19L squared minus, yeah, at the top.
Now, since I have P, we can continue with P.
Yes.
Okay. But this variable doesn't matter. Okay, since you said I start with Q, I will continue with Q. Okay. And then we have 38 times 10 minus, so this means we have 380 minus 270, and this will give us 110. Oh yeah, we have 110. So this means employing one more worker will lead production rate of 110 units. Yeah.
Okay, so we don't have to go and stress about the average production of labor. If we are asked, if we're adding one more, we can just use the marginal production of labor function.
I think it's got to do with how the question is maybe asked. That's also another thing.
Yeah. Okay. Nolwazi, you still there? We can't hear you.
Hi, ma'am, we can't hear you.
the average production per worker, then you use the average production. Let's say you are asked to find you are given one more person. You are asked what would be the marginal production of labor if
Sorry, ma'am.
you hire one more person. Yes.
There was network issues, so about maybe a minute or so we didn't actually hear you. So there was a network notification on your on delay. So the last minute played of the sound played in warp speed, yeah. So if you can just repeat what you just mentioned, please.
Okay, I was saying if you are asked to find the average production per worker, that means you find the average, like you use the formula average production labor, right? But if you are asked to find the production, if you hire one more employer, if you employ one more worker, then that means you'll find the marginal production of labor. We use the marginal production of labor and use the number of workers that you have, and from the marginal production of labor, and that will give you the marginal production of labor if you hire one more person. That will tell you employing one more person will produce how much is it rates of units is the work that will be done in that day. If you hire one more person, then you go for marginal production of labor. But if you are asked to find the productivity per person, you'll solve for the average production of labor.
Okay, thank you so much, sir.
Okay, ma'am. Thank you so
Got
much.
it.
Thank you.
Do we have any more questions? Let me see, how many topics do we have? No. Okay. Next time, I think and okay, before I continue saying this, do we have questions here on this section that we did today?
I have a
Ma'am, I have a question. Can you please repeat the last part which you have just explained now? I didn't get it right.
Okay. The last part I said, if you are asked to find the productivity per each person working for you, then that means you will solve for the average production of labor, right? But if we are asked to find the outcome after hiring one more person, then that means you'll solve for the marginal production of labor and use the quantity and the number of workers as the ones that you have employed already, right? If you want to find the outcome of hiring one more person, you'll solve for the marginal production of labor. If you want to find the productivity per each work, then that means you'll solve for the average production of labor.
Okay, thank you. Thank you. I got you now. Thank you so much.
Thank you. Okay, I've stopped recording.